Hi, welcome to MyProjectBazaar.com. Now let me discuss about the title of the process. The title of the process is Discovering Binding Course in Protein DNA Binding Using Association Rule Mining with Statistical Measures. Then now let me discuss about the objective of the process. The objective of this work is to generate much lesser number of frequent item sets in protein DNA interactions than the state-of-the-art association rule mining algorithms. The most biological significant association rules to be found which hold very poor rank in a priori. To vary the support threshold and maintain the same confidence threshold, by doing so more strong rules are identified in our process. Now let me discuss about the abstract of our process. Understanding binding course is of fundamental importance in deciphering protein DNA, that is called TF-TFPA sequence. So in that binding and for the deep understanding of gene regulation. So these are the critical issues in our process. So traditionally binding course are identified to solve high resolution 3D structures. However, it is expensive, labor intensive and time consuming to obtain these structures. Hence it is promising to discover binding course computationally on a large scale. Previous studies successfully applied association rule mining to discover binding course from TFPS binding sequence data only. Despite the successful results, there are limitations such as the use of tight support and confidence thresholds, the distortion by statistical bias in counting pattern occurrences, and the lack of a unified scheme to rank TF-TFPS associated patterns. In this study, we proposed an association rule mining algorithm incorporating statistical measures and ranking to address these limitations. Experiment results demonstrated that even when the threshold on support was lowered to one-tenth of the value used in previous studies, a satisfactory verification ratio was consistently observed under different confidence levels. Moreover, we proposed a novel ranking scheme for TF-TFPS sequence associated patterns based on p-values and curve support values. By comparing with other discovery approaches, the effectiveness of our algorithm was demonstrated. 84 binding courses with DB support are uniquely identified in our process. These are the main objective and abstract of our process. Now let me discuss about the data flow diagram of our process. First, our process interface interacts with the user interface. In that user interface, we have to select the 3D protein DNA complexes dataset. After we select the dataset, we have to load the dataset into the database. After we load the data into the database, we have to apply the free filtering mechanism. In that pre-filtering mechanism, we have to normalize the data. In that normalization, we have to extract the variables or values in the dataset, which is dataset contains float values like that. After, by using lemma to identify the binding sequences. After that, we have to rank the binding instances with respect to their calculated p-value. After that, we have to assign the weight value to binding instances with respect to p-value. After we complete this process, we have to discretize the data. After we discretize the data, we have to apply the Ranver algorithm. By using the Ranver algorithm, here we are going to propose or develop an ontology based dynamic support count values. After that, we have to update into the database. After, we have to apply the TG and TM and the WC values. By using that, here we are going to calculate the similarities between TG, TM and WC. After that, here we apply the similar and non-similarity value for first and second queries. By using that, here we calculate the ontology. After, by using that, here it returns similar queries. So after that, here we find the lower and upper bound values by using the existing algorithm, and here we compare UQTS algorithm. We finally predict the DNA sequences of the particular process. This is a complete data flow diagram of our process. Now let me discuss about the complete demo of our process. First, here we have to run home.java. So just click on that frame. and right click on that frame and click run file. So in that here we have to run our package that is called discovering finding. That we are having a lot of files. We have to run home.java file. So after you run that particular home.java file, that page will be opened here. In that particular home.java we are having our title frame that will be displayed here. So this is the home page. Our title is discovering binding codes in protein DNA finding using associational mining with statistical measures. After you click the next button, it will redirect to the dataset selection process. You have to select your dataset. So our dataset is dataset.csv. Then click open, and this is our dataset. This is a serial number, then particular DNA sequences. After that, click next button. We have to load the data into the database. After the data will be loaded, we have to pre-process the data set. In the pre-processed data, null values will be deleted. Here we are reviewing our data set, that is ID, TF sequence and TFB sequence. Then click next button. Then here we are implemented algorithm. Here we are calculating the support value for that particular sequences and confidence value. Here by using support and confidence, here we estimate the p value. Then click next button. Here we are calculating p value by using the p value. Here we calculate the DF sequences. After that we have to assign the weight. Here we are assigning the weight to each binding instance with respect to their p value. Then click view. ID, TF sequence and TFP sequence will be displayed here, and click next button. Data discretization has been applied. Here we here we find exact protein sequences. Then click find sequences. Here we find the sequences, and here we are generating the ontology. So it will be redirected into our browser. Then here we click the evaluate button, means our proposed system and existing system. Here we calculate the true positive rate and false positive rate, and by using that here we evaluate the process, and by using the p value and control and verification ratio, here we evaluate the process. And when you click the enhancement button, here you have to enter your support value. So here we are applying efficient ontology query based dynamic support count for multi-dimensional association rules mining. So you have to enter your support value. So enter, you have any support values and confidence value. Go to the database. That particular database, our database is discovering binding. So in the database we have to extract our confidence value. So by using that confidence value and on support value, we are going to construct the ontology. So we have to enter your confidence value. You need to just enter your confidence value also, and click get. Successfully got the values. Then get ontology has been estimated, and you have to enter your weight value. Just enter weight value and click search, and then click next. Here click the view. Based upon the information, here we identify the TFB and TFS sequence. The type result counts are. So by using that, here we evaluate the proposed ontology and previous ontology, non-similar and comparison time based upon the proposed and previous. This is the complete demo of process. Thank you for watching.